Hello guys, my name is Frederick and today we are going to talk about multiplexer and decoder. We are going to draw an architecture for multiplexer and a decoder. We are going to draw simply the architecture for a 8x1 multiplexer and a 16x1 multiplexer. That is 18 inputs and 1 output, 16 inputs and 1 output. And we are going to draw the architecture for a decoder, that is the 3x8 and the 4x6. So before we start with the drawing, let us look at what a multiplexer is. A multiplexer is a digital device that selects one input from several inputs and sends it to a single output based on control signals. And a decoder is a digital circuit that takes binary input signals and activates only one, selects output lines, and depending on the input combination. So without wasting much time, let us dive into it and start with the 8x1. 8x1, that's the multiplexer. So for the 8x1 multiplexer, we are going to with our truth table. After solving our truth table, this is what we are going to get for the 8x1. We are going to get a 3 out because it's 8 to the power, so 2 to the power n equals 8. So 2 to the power 3 equals 2 to the power 3. That means our n becomes 3. That means our number of select lines will be 3. So we have 3 select lines. So this is our table. This is what we are going to use to test or draw our architecture. So let's start by putting in the gate, the NOT gate. I would like to put mine here. Change the direction and bring it to south. Yes, when it's south like this. Yes, so I'll just copy and paste it, put the next one here, copy and paste it, and I'll put the next one here. So yes, we are going to join it to the positive. This is the NOT. We are going to join the NOT to the positive. So this will be our positive over here, and this will be our NOT over here. Yes, so let's extend the NOT to this side because we'll be adding a switch like this. So here we have it. We have our select lines over here. What we are doing next is we are going to add our pins and label them. You can see here it is supported, so our pins are supported. Now what we are going to do next is change the name of our pins. So our first will be the S, our select line S0. S0. We have S0 over there, and we have S1. We have S1 over here, and we have S2. Sorry. Yes, S2 over here. So our select lines are ready. Now we are multiplying them. We are not using the multiplexer. We are using the AND gate and the OR gate. So because they are multiplying, we will use AND gate. So an AND gate, one will be over here, and our AND gate is going to have 3 outputs. Sorry, our AND gate will have 4 outputs, 3 connected to the select lines and 3 inputs. Sorry, 3 connected to the select lines and 1 connected to a pin. So we have 4 over here. Yes, so the 4 are just 8 over here, and our AND gates are connected to an OR gate. Let's just put our OR gates here, and our OR gates will also have number of inputs 8, since we have 8 AND gates. So first I would want to, there's no particular order. I'm doing this in no particular order. I would want to connect the AND gates to the OR gate first. So, and after that I'm going to add output. That's one output because it's 8 to 1, so we have only one output. And I like to use a LED, so I'll use LED as my output. over here, and I'll change the color. So the on color here is red, I'll change it to green, and the off color here is black, I'll change it to red. So we have red over here. So when it is off, it is red, and when it is on, it is green. So after doing this, we are going to connect the end gates to the select lines and the switch and the pin using the logic table. So I'm just going to put my logic table over here so that it will help me whilst I am doing this. So for the first one, I have 0 0 0. So the first gate for the first one is 0 0 0. I'll use my first line here as the switch, as the pin. Yes, and our first line will be 0. That is the knot connected to the knot, and the 0. Another 0 over here, another 0 over here. And I7, we have 1 1 1. So we have this, and we have 1 1 1 1. So we have 1 here, we have 1 here, and we have 1 here. So let's connect the pins to the end gate. Now here you have it. So for I1, I mean, we are done with 8 by 1. For I1, all the selectors are 0. So we have 0 0 0 selected. So that means when I turn on the I1 over here, my LED is supposed to on. So let me turn on my simulate over here and turn it on. And here we have it over here. I0 is on and on. And for the last one, that is I7, all the selectors are 1 1 1 1. So 1 1 1 for all selectors. So I'll turn on I7 and my LED is on over here. Let me turn it off and try another random number. A number like I4. I think there was a mistake with the I4. So it's supposed to be 1 over here, not 0. So let me delete the lines and draw another one. 1 over here. Yes, so when I turn on the stimulator for I4, it's off. When I turn on S2, it is on. So here you have it for the 8 by 1 multiplexer, and we are going to continue with the 16 by 1. So we are going to continue with our 16 by 1 multiplexer, and 16 by 1 we have 2 to the power 4. That means you are going to have 4 select lines. 4 select lines, and one we have 16 inputs and 1 out. So over here we are using the AND gate and the OR gate as well. So we are going to have 4 select lines. So I'm going to have my not 4 select lines, not gate 4 here. So we'll continue with our switch, our pins over here. Okay, so here we have it. Now we need 16 AND gates. Okay, so we are going to continue from here. We are connecting the lines. So I think I have to start from the bottom here. Good, and I'm going to connect this to a LED as usual. I'll change the on color to green, the off color to red. Yeah, so when it is on, it's green. When it is off, it is red. Now for I0, I'm going to connect the AND gates to the selectors and add the pins. Okay, so here you have it, our 16 by 1 multiplexer all done. I'm going to test it. So LED is red, that means it's off. So this is our 16 by 1 multiplexer, and you can try it. It's 000 less than our stimulator. I0 select 4 zeros, all are zeros. Turn a stimulator here and it is green. Let's try I5 where we have 0101. So 0101 and I5. I5 is green. We can try it for all the others and it will work. It will work. So that is it for our 16 by 1 multiplexer.